Hello everyone. Today we'll discuss about model 2. We'll discuss about system and properties of system. Basically a system which manipulates a signal and produce one more signal. The characteristics of input and output signals are different. So system which process input signal and produce output signal. And the system is a combination of elements that manipulates one or more signals to accomplish a function and produces some output. The figure shows a block-diagram representation of a system. The system, the signal, the input is signal and the output is also signal. The characteristics of input and output signals are entirely different. The example for a systems are communication system and control system and so on. So next we'll discuss about properties or classification of system. There are different properties of systems. It's given below: causal and non-causal, linear and non-linear, time invariant and time variant system, stable and unstable, static and dynamic, invertible and inverse system. We'll discuss the properties one by one. Causal and non-causal system. A system is said to be causal. The present value of the output signal depends only on the present and or past values of the input signal. The example, the y of n is equal to x of n plus 1 by 2 and x of n minus 1. Here, the y of n is output signal and the x of n is the present value of input signal, x of n minus 1 is the past value of input signal. Suppose the present value of output depends on the future value of input signal, then it's called as a non-causal system. So system is said to be non-causal. The present value of output signal depends only on the future value of the input signal. The example of a causal system: the voltage across a capacitor. The real-time example. Basically, the capacitor and inductors are storage device, and you will relate the input and output signal by equation y of t is equal to 1 by c, the integral over minus infinity to t x of tau into theta, where x of tau is input and y of t is the output signal. So your integration indicates that it depends upon the past value of input signal. Similarly, one more example, y of n is equal to x of n minus 1. So present value of input depends upon the past value of input signal. The example for a non-causal system, y of t is equal to x of minus t. So here, the present value of output depends upon the future value of input signal. For example, if I'll consider t is equal to 1, then y of 1 is equal to x of minus 1. So present value of output depends upon the future value of input signal. Similarly, one more example is y of n is equal to 1 by 3. X of n minus 1 plus x of n plus x of n plus 1. Here, the x of n plus 1 indicates the future value of input. So, the system is called as non-causal system. The second property is a linear and non-linear system. A system is said to be linear if it satisfies this principle of superposition. To prove the superposition property, you will consider two or more signals. And here, the superposition principle states that the weighted sum of input should be equal to the weighted sum of output. So here I'll explain in terms of two input signal, and I'll consider two systems here represented as y1 of t is equal to the function of x1 of t. That is, x1 of t is excitation and y1 of t is a response. And y2 of t is equal to f of x2 of t, that is x2 of t is excitation and y2 of t is a response. Then for this linear system, the function of the linear combination of input, that is a1 into x1 of t plus a2 into x2 of t, should be equal to the linear combination of output a1 into y1 of t plus a2 into y2 of t, where a1 and a2 are constant. So if it is equal, then the system is called as a linear system. If it is not equal, then we'll call it as a non-linear system. We consider an example, like y of t is equal to x square of t. The output of the system for two inputs x1 of t and x2 of t becomes y1 of t is equal to x1 square of t and y2 of t is equal to x2 square of t. The linear combination of this output becomes a1 into x1 square of t plus a2 into x2 square of t. And similarly, the linear combination of input results in a1 x1 of t plus a2 x2 of t whole square. If I'll expand that, if I'll compare y3 of t and y3 dash of t, then it is not equal. So the above system is called as nonlinear system. Next we'll discuss about time invariant and time variant systems. A system is said to be time invariant if a time delay or time advance of the input signal leads to a identical time shift in the output signal. The meaning is whatever the delay or advance in input signal should result identical delay or advance in the output signal. If it is achieved, then the system is called as time invariant system. Otherwise, the system is called as time variant system. We'll consider some examples. The y of t is equal to sine x of t. The first we'll delay our input signal by t1 here. So we'll consider equation y of t comma t1. So we'll delay the input signal on wherever x of t is there, we'll delay by x of t minus t1. So my equation is sine x of t minus t1. And next we'll delay the output. So wherever t is there, we'll delay by t minus t1. So the second equation is y of t minus t1 is equal to sine x of t minus t1. So if I compare equation 1 and equation 2, in this case it is equal, the system is called as time invariant system. If it is not equal, then the system is called as time variant system. Then third property we'll discuss about stable and unstable system. System is said to be bounded input, bounded output stable. It is bistable if only if every bounded input results in a bounded output. So we'll consider the condition. Your absolute value of x of t should be less than or equal to mx less than infinity. That is a condition for a bounded input. And similarly, we'll consider the condition for a bounded output. That is absolute value of y of t should be less than or equal to my less than infinity. So for every bounded input should result in a bounded output, then we'll call it as a system is stable. It is the system of bounded input result in an unbounded output, then we'll call it as an unstable system. So the example, moving average system, an example, the y of n is equal to 1 by 3 x of n plus x of n minus 1 plus x of n minus 2. In this case, the output depends upon input signal only. As long as my input signal is bounded, output is also bounded. So we'll call the system as stable system. The fourth property we'll discuss about static and dynamic system. The static system is also called as a memoryless system, whereas a dynamic system is called as memory system. A static system is a memoryless system. It has no storage devices. So it's, in terms of signal, the present value of output depends upon the present value of input signal only. Suppose if it depends upon the past and future value of input, then the system is called as a memory system. In the real-time example, the voltage across a resistor or a current to the resistor is I of t is equal to V of t by R. So basically the resistor is a static device. Dynamic system which processes memory, it has a storage device. The system is said to process memory if its output signal depends on past value and future value of input signal. So it's also called as a memory system, or it's also called as a dynamic system. An example is the voltage across the capacitor. Examples, so y of t is equal to r into x of t. So the present value of output depends upon the present value of input only. And the second equation also, the y of n is equal to 2 into x of n plus x square of n whole square. Here also, present value of output depends upon the present value of input only. The second examples here, y of t is equal to 1 by c integral over minus infinity to t x of tau into d tau, the voltage across the capacitor. So it depends upon the past value also. So system is having the memory. Similarly, y of n is equal to x of n minus 1. So present value of output depends upon the past value of input. So system is having the memory. So next we will discuss about invertible and inverse system. A system is said to be, a system is invertible. It has an inverse system. So here, if I am able to recover my recover the input from the output of a system, then system is having the inverse. So that type of system we'll call it as a inverse system. For example, here the two systems are mentioned. One is system 1, another one is a system 2. So for system 1, the input is x of t and the output is y of t. That output y of t is again fed back to, given to the inverse system and results in x of t. So, and the system and its inverse system, so I am able to recover my input from the output. So that type of system is called as invertible system. If I am not able to recover the input from the output, then it's called as non-invertible system. The example is your integrator and the differentiator. Suppose y of t, will use some integral operator for my input signal, and if I want to get back my input signal, if I'll apply the differentiator operator to that, I'm getting the input signal back. And similarly, multiplier and a divider. The example is shown. The system 1 is a multiplier and the system 2 is a divider. So x of t is equal, x of t's input signal is provided, and the system, you are multiplied with some constant over there, y of t is equal to into x of t. If I want the inverse of that system, then I will divide by 2. So I'll get my x of t's back. So multiplier and dividers are the inverse systems. So this is about the different properties of a system. So we discussed about causal and non-causal system, linear and non-linear, time invariant and time variant system, stable and unstable system. And then we discussed about invertible and inverse system. And finally we discussed about the static and the dynamic system. So, and we'll discuss. Okay, thank you.